Hello and welcome back to Engineering Open House Day Live. I'm Mark Reynolds, your host for today for this live-a-thon, and we are giving you a huge insight today in what it's really like to be an engineer or technologist today, with exclusive behind-the-scenes access to organisations right across the UK. Get my teeth in. We've had such a fun jam-packed day already today. It's just flying by though, it's going so quick. We launched our live show in episode 1 with a trip to space with some epic guests including Sophie Harker, Jack Hesselwood, Mr. World and Vanita Mawaha-Madil. And then we plugged our brains into an hour all about electricity when I was joined by my sidekick and co-host, President of the IET, Danielle George. And if you missed the last 2 episodes, don't worry. All the episodes will be available on demand after today. But the fun doesn't stop yet. We've got another 3 episodes to come. We still have so many exciting things happening for the rest of the day. So let's have a quick look at what is coming up. Well, in this episode, we'll be diving into the world of transport and highlighting the innovations engineers today are working on for the future, before powering our brains with energy and sustainability, and then finishing off our jam-packed day with our innovation episode to see what the future of engineering could bring. So please remember to visit the Media Hub, where there are tons of virtual events happening. You can explore the world's first practical computer that was made at the University of Cambridge with the National Museum of Computing, or you can explore the world of water with Thames Water. There's just so much to be involved with. And don't worry, like I said, if you can't multiply yourself and attend them all at the same time, they're all available on demand. But it's post-lunch, and I don't know about you, but I think I need a sweet treat. How about you at home? Do you fancy something nice and sweet? I think it's time for a foodie experiment with some solar-powered pizza box oven s'mores. Greg Foote and Maddie Moat, presenters, podcasters, and YouTube stars and lovers of all things science, technology, engineering, and maths. Maddie's a BAFTA award-winning STEM presenter, and Greg is a professional science presenter, podcaster, and YouTuber, and they've created Let's Go Live with Maddie and Greg, a hugely popular live science show for families and children of all ages, streamed on YouTube. So let's go and see them in the studio. Hi, Maddie and Greg, you there?
Hi, Mark.
It is time to cook up some tasty treats.
Yeah, who is ready to make s'mores using the power of the sun?
Everyone is, Maddie, but especially me.
Yeah, to be honest, there's not much better than melted chocolate and marshmallow smooshed on top of a...
Smooshed.
Is a word.
Yes.
On top of a digestive biscuit.
You're right, there's not much better than that. But before we get into that chocolatey treat, let's talk about solar energy and what we can do to use it.
Right, good plan. So I'm sure you have stood outside on a sunny day and felt the light and warmth on your skin. Well, that is solar energy. We can use it, we can turn it into electrical energy.
Yeah, but in order to capture that solar energy, to convert it into electricity so that we can power stuff, that takes a special bit of equipment, some really cool technology. I'm sure you've seen them on the roofs of some buildings, kind of black-blue rectangles. They're called solar panels. Inside solar panels are solar cells. Yeah. You also might have driven past a field that's full of row upon row of solar panel. We call those fields, we call that a solar farm.
I love solar farms. They always look so futuristic.
They're great.
But how does a solar panel work? Well, energy from the sun is made up of teeny tiny things called photons. When photons hit the top layer of a solar cell, it causes other teeny tiny things called electrons inside the cell to start moving around. They get excited and then eventually they start to flow out of the solar panel, and we call this flow an electrical current.
Yeah, so in order to capture, right, that renewable source, sunlight, that solar energy, convert it into electricity so that we can actually power stuff, gadgets in our homes, maybe even an electric car, that uses this brilliant bit of technology, a solar panel.
Now, we're not going to be using a solar panel in the make we're doing today, but you will need a sunny day to power your pizza box solar oven.
And to make one, this is what you could use. A pizza box, some card, some foil, tape and scissors, cling film, a pointy stick, and some blue tack, and of course, your ingredients.
Yes.
We're going to start with the pizza box, and what you need to do is to cut a flap in the top. Now, this is a bit tricky, so you might want to get a grown-up to help you, and be careful as you do so. You cut 3 sides, 1, 2, 3. The other bit is where you fold back like that. Then, then you take your kitchen foil.
Yep.
And you cut it to be the same size as the lid on the top. And then we're going to stick that in.
Oh, okay, so it's not the same size as the lid.
No, it's the same size as the flap.
The flap,
Good
okay,
point.
got
Yeah,
it.
so stick that down like that.
Any special way?
Yeah, the shiny side. See, there's a shiny side and a dull side. You want the shiny side facing into the box.
Okay, all right.
Like that.
Okay, so I have now stuck the foil down to the flap.
I've got a bigger bit.
Yep.
And this bigger bit is going to line the inside of the box.
All right, okay.
So we put this in here like this. I mean, it's not going to look very neat whilst I'm doing it, but you know.
If you decide to make your own solar pizza box at home, you could take a lot more time and make this nice and neat.
That kind of works.
Beautiful.
Next thing, cling film, okay? Open the flap and the cling film goes on the rest of the top bit of the box. Does that make sense? Let me show you, it'll be easier.
Here we go.
There you go.
And also, you don't have to use cling film, you just need to use a clear piece of plastic. So if you have, I don't know, perhaps some clear plastic packaging in the recycling bin at home, then you could always cut out a piece of plastic. It just needs to be a little bit larger than the flap. So you can see here, we've got the flap with the silver foil and then the cling film here.
Now, you need to be able to prop up that flap.
Right, okay.
So let's close up the box.
Yep.
Or our pizza box solar oven.
Hang on, I'm just going to do this carefully because our silver foil inside is loose.
Didn't do the neatest job, to be fair.
That's okay. Let me do it this way so you can all see it.
This one's got a spike, so be careful of the spike. But what
There we
I'm
are.
going to do is I'm going to spike this. Watch your finger. I'm going to spike this in the corner, like that. Okay, and then this is going to rest on there. So I'll just put a bit of blue tack like this, and that will just rest on there.
I see what you've
that
done.
works. Fine. That is your solar oven pizza box ready, but now you need to actually make your s'mores. So,
How do you make a s'more?
Yeah, exactly. Well, as a plate, I've used a bit of black card, okay, and we've just chopped that up to make sure it fits inside the pizza box.
Okay.
So, to make your s'moresome s'more, biscuit.
Yeah.
Okay, should I make two? I'll make two. Biscuit.
You could use any type of biscuit, but plain biscuits tend to work best because you're about to load them up with
Chocolate. Oh, yeah.
thin squares of chocolate work really well, actually.
Marshmallow.
You're being very conservative for you. Just one marshmallow on top.
It's good with one, trust me, it will melt so well.
right.
Okay, and then this plate goes inside the pizza box like this.
And it's important that you've used black or dark card as your plate as
yeah.
well. We'll explain why that is later.
Yeah.
So now I'm going to shut up the solar pizza box oven again, and you can sort of see how the lid goes on.
Yep, nice.
And then we have the piece of cling film separating the box and the flap, and then we'll prop the flap open with our stick and the bit of blue tack. Remember, this is a solar-powered pizza box oven. So how do you think it's going to work to cook our s'mores that are inside? Well, whilst you have a think about that, here's what happened when we put another one of our pizza boxes out in the sun. Our pizza box solar oven works by collecting heat energy from the sun and uses that to warm up our s'mores.
You need to make sure that it's always facing towards the sun and open that lid, that flap up as much as you can to direct as much sunlight in as possible.
That's because the shiny flap that we made is bouncing sunlight into the pizza box. And then the cling film lid, that's acting a little bit like a greenhouse roof, trapping that heat energy inside the box.
And the black card is great because that's absorbing a lot of that heat, which means it keeps the food warm as well from the bottom.
We love this activity because it's fun to make. It shows us how we can use renewable energy, but also
It's
we
delicious.
get tasty treats
Yes.
at the end.
If you want to see some more brilliant STEM activities, head on over to the Engineer a Better World website. And coming up later on, as part of Engineering Open House Day, we've got another little build for you. That one is going to be capturing the power of water, hydropower. Got a feeling it might get a little bit
Wet. Yeah. However, back to you in the studio, Mark. How are your s'mores?
They Oh, amazing. I mean, thanks for these tasty treats, guys. Look, I'm not sure I should even buy, I might have, should I have a little bit? Oh, I shouldn't have done, but they are really good. Thank you so, I can't speak now. Thank you so much, Maddie and Greg. It wasn't a great idea, but I love it. Oh, they're really chewy. And I think Greg and Maddie could give Andrew's Baconeering a proper run for his money. Honestly, they're going to disappear. I know one of the cameramen has got his eye on those. But before we leave you to eat your schmores, you both need to take part in our Paperplane challenge, don't you? So to the side of you, you'll find your paper, pens and stickers, and you've got to create your plane. And we'll give you 60 seconds on the clock and see whose plane goes the furthest. And for those at home, you can get yourself up here with our engineering experts on our board. All you need to do is to ask for your parent or guardian to send in the video of your paper plane with your name and age on new social media using the hashtag EOHD Paperplane, and you could be in with a chance of winning a really cool STEM prize. Terms and conditions apply, so please head over to our website before you join in. So Maddie, Greg, are you ready? 3, 2, 1, let's go!
Okay, bring it on.
Yes.
All right then. Okay, so I've got the materials.
Hashtag Team Greg, or are you hashtag Team Maddie?
Well, let's just move the solar oven out the way. Biscuits, move those.
Brain energy.
Sure, okay. All right, so we're gonna need some paper. We've got materials. That's it. We're not using our time right now. Hang on, excuse me. You might not want decoration, I do. Okay.
Okay.
Ready?
Yes. 3,
2, 1, start the clock.
You've got to make it before you colour it in. Whoosh! Does that make it go further? How long have we got? That's right, it's only 15.
Okay, all right. So I'm going for a classic design.
The old dart.
Yeah, okay.
Oh, I should have
I've got shaky hands.
I should have spent longer.
What are you doing?
We're almost at halfway.
No, already? Oh no,
Oh no, I should have
seconds.
spent longer making it balanced. It's going to be a wonky one. Mine is also the dart, but the other way round with the initial bit of
35
paper.
seconds. Okay. I've forgotten how to make a paper plane. Here we go. I'm going over now, like this. I'm folding it in half again.
ready.
44 seconds.
15 seconds left. Do I want to add
Oh, shaky, shaky, shaky.
Maybe I'll add a little extra.
We have
10
50 seconds.
9, 8, 7, 6, 5.
4, 3, 2, 1, stop.
Okay.
Okay.
Yes.
I technically made 2.
Oh, you have technically.
Yeah.
Are you counting that as a paper plane?
Yeah, this is one. This is my whoosh ball paper plane.
Oh, that's what you wrote whoosh on.
And this is my classic design.
Okay.
Okay.
Yeah, I'm so ready for this.
There was no rules about how many you could make.
Very true. Always finding a loophole. Okay.
You ready?
I think I might have mucked up my design with these flaps. I think I should have just stopped.
I'm nervous. Are you ready? You're going to go first?
Well, you've got 2 to throw,
Okay,
so you
well, I'm
throw
going to go
one.
with this one first then.
Okay,
All right, so this is my
dart.
classic dart.
Yeah.
All right, okay. Ready? 3, 2, 1. Woo!
That was brilliant.
Good. That was good.
That glided.
Don't mess with the classic designs, you see? Go on then.
Okay.
Ready?
Okay, ready?
3, 2, 1.
Oh, no.
It's got a loop the looped.
Do I get bonus points for gymnastics?
Mark? I don't know.
No,
okay, I'm just going to do my second design.
Yeah, I think this could
Ready?
win. It's definitely going further
This
than
could be
mine.
our joint one as well. I tell you what, I made it. You've probably got a little bit more muscle power than me, so you get to chuck
No,
it.
you're pretty strong. Okay,
All
you
right,
ready?
then. So this is our joint playing
Okay,
efforts.
right.
3, 2, 1, go.
I could, you know what? That could take the leaderboard. That'd be really embarrassing if a not plane took the leaderboard.
So are you hashtag Team Greg, hashtag Team Maddie, or hashtag Team...
Maddie and Greg.
I was going to say Graddy. I'm so glad I didn't go for that.
Yeah.
Anyway, back to you, Mark. How do we do?
So, Maddie, I'm not sure we can count that swoosh one, but we have got your scores here and your distances. And you've not done too bad, actually, Maddie. It was 3.83 metres, so you've not gone into the lead, but you have gone above Sophie Harker there. Let's put you up there. And Greg, 3.27 metres, and he's got 2 bonus points. I don't think they really count, but that was for the acrobatics, which we saw, which was brilliant. And other thing as well is just before we left you from the last episode, we had a fabulous Dangerous Dan in here, and we were doing all sorts of stuff, but we ran out of time to do his Paperplane. So what we did is, in the interval there, when there was a video playing, we actually filmed him, which is going to be available on social media in sort of the next half hour or so. It could already be there, I don't know. But we did measure it, and to be honest, we're really disappointed we didn't film it live because, would you believe it, it went over the top of my able assistant down there, 15.54 metres. And you can see why they call him Dangerous Dan. That was incredible. Big round of applause to Dangerous Dan. I'm going to have to move them all down a bit now. 15, that's like... And yeah, so have a look out on social media for that because it really is a long throw. Probably, I mean, it was the whole length of our studio. And you know, I think if it had a run-up, it would have gone the other side. So there we go. Dangerous Dan has jumped above Mr. World, so and we're there. So let's get back over here. They were lovely, those s'mores, by the way. Thank you so much for showing us how to do that, especially with the sun as well, just melting them with the sun. How cool is that? Now we've all been fed, hopefully, and you've been fed at home, so we can start our engines and go and see an exclusive behind the scenes at the World Finals of the International STEM Competition for Kids and our IET education partners F1 in Schools. And for this competition, teams must design and manufacture a miniature car. Here we go, like these, look. And it's out of the official F1 model block using CAD design tools, and then they race them to the finish line to be crowned the race winner. So let's have a look at that.
Running through the lights of my thoughts, standing on the edge of my jump. Everything I know will be gone in a minute, and that's alright. Running through the lights of my thoughts.
Welcome to the Aramco F1 in Schools World Finals. We are coming to you live from the F1 in Schools global headquarters based at the Denford Engineering Facility in Yorkshire, England.
Everything I know will be gone in a minute, and that's alright. Alright, 'cause I'm freer than I've ever been before.
In taking part in F1 in Schools, you're rising to this challenge and equipping yourselves with the skills needed for work.
Alright, 'cause I'm free.
Congratulations to all the F1 in School teams who have made it to the World Finals.
I am proud to declare the 16th World Finals of F1 in Schools open.
So we're coming towards the end of day one of the competition. Does it feel like a World Finals? Definitely.
Welcome along to day two of the Aramco F1 in Schools World Finals. It is day two of racing, and we cannot wait to get started.
Alright, 'cause I'm free than I've ever been before. Yeah, baby, I'm free than I've ever been before.
Just the way this has all worked, it's been incredible. And then the build-up and the atmosphere before we head up the racetrack has been off the scale. It's been brilliant.
Good morning, good afternoon, and good evening. Welcome along to a very exciting day of knockout racing.
The atmosphere has been absolutely amazing.
Teams themselves, I mean, their enthusiasm through Zoom has been just second to none.
We are in the final of the knockout competition. Congratulations to Quince Lux.
We are so thrilled here to finally be competing and this afternoon handing out awards and crowning our world champions as well.
The Formula One is really believing in this project in its entirety.
The truth is that everyone who made it to this F1 in Schools World Final is already a champion.
I think this is awesome F1 in Schools.
Running through the last of my thoughts, standing on the edge of my time.
Ladies and gentlemen, boys and girls, the winner is from the United Kingdom, Britannia Red.
Many And once again, congratulations, ladies and gentlemen, to our world champions, Britannia Reds.
Wow, how much fun did that look? And great music too. We were all having a dance here in the studio. Brilliant. I bet that's amazing to race your own little F1 car that you and your school friends all made together. How brilliant would that be? We can't believe how much work goes into it. And when you actually see these super speedy cars. But now from these models to the real thing, from drawings all the way to customers in the field and balancing her time between experiments and meetings, Ella Podmore, our Young Woman Engineer of the Year award winner in 2020, is a materials engineer for the luxury British supercar maker Mclaren Automotive. She created this little department and now growing from the ground up. So let's have a look at what Ella does at Mclaren Automotive.
There's so much more to engineering than solving problems and fixing things. So what makes an engineer tick? Growing up, I love science. Experiencing firsthand the impact it had on the world and people around me, I knew early on that I wanted to get involved. There was always this great urge inside of me that strived for performance. But why did I become an engineer? To make something better than anything else, to break records, to go faster. I always pushed myself and my work to the absolute limit. Sport had always been a channel for this competitive edge. My desire to evolve my process and my practice, being part of a sports team really taught me that some of the smallest changes are often the most important. How pushing yourself can excel an entire team to success. That feeling of wanting to be a part of a dynamic team environment, that's what drew me to Mclaren. And being the company's first materials engineer, I'm so fortunate that I get to work on some of the world's most advanced materials. The changes that I make are really small, they're microscopic, but it is at this microscopic level where we make the difference. And it is here where we're able to make a lightweight car even lighter, and here where we're able to fine-tune that product for performance. Working on some of the world's fastest cars makes me feel like part of a materials technology movement. And I want to use this platform to broadcast all the work that those materials engineers are doing on a microscopic level to better industry. For the young girls and boys who are looking to engineering for a career, wondering if it's quite right for them. But for me, more importantly, I want to use this platform to broadcast the work that engineers out there who are doing more than just safety and function. Why not take it to the edge? I have found engineering to be groundbreaking, beautiful, and I cannot wait to see where this winding road takes me next.
And speaking of supercars and we're joined by Ella live with us in the studio. Ella, you actually made it in here. Brilliant, woo! Oh, this is fantastic. And gifts, obviously gifts. I think this is what this is, isn't it? But you've actually brought in a Lego supercar with you.
I brought you a few toys, Mark. Wow. I thought you were having way too much fun. So.
Yeah, look at these. They're amazing. And did you make this one?
I did, yeah, a bit of homework prep before the show.
Brilliant. So how on earth did you end up working for British supercar maker Mclaren? That's a fantastic story.
Well, I'm very, very lucky. It all started back in school. I loved science. I loved chemistry in particular. I wanted to fix problems, solve things, and contribute to industry. So I knew that I wanted to be an engineer probably quite early on, but I didn't even dream of cars. I wanted to, like I said, be an engineer and sort of fix problems, and it took me down materials engineering route at University of Manchester. And I'll never forget the day when I was filling out all the application processes for internships and stuff, and I had a big poster of a McLaren P1 on my bedroom wall. And it was just something, I grew up watching Top Gear with my dad. I loved watching cars on TV. It was just something so exciting, but to me it was just TV. And when I was looking up at this poster, I thought, why not apply to McLaren? And I wrote them a letter. They didn't have an opening. I wrote them a letter. And it was a great life lesson that you've just got to grab and seize these opportunities, because I got a 12-month internship and then they invited me back, and I've been there 3 years.
Wow, fantastic. And what does a normal day for you look like at McLaren?
It's pretty wild. As you saw from the footage, it's very James Bond. It's very, very humbling office to be in.
It's amazing, isn't it? Just amazing.
I know, but it inspires you. Mm-hmm. So every day I go there and I think, how are we going to make this better? How are we going back to that performance element? I think every day I'm surrounded by beauty, surrounded by like unbelievable engineering. And so every day I'm going in saying, what can I do? But generally, I spend a lot of time in the lab, so my work is quite experimental. We want to push the boundaries where we put materials, how lightweight, how strong, what the aesthetics of them look like. So quite a lot of my time is doing experiments to make sure that if we have really high UV conditions, it's still going to remain this color. If we're going to put it through these amounts of pressures and temperatures, it's still going to be structurally sound. So have a lot of lab time, but then I get to see them as well. Be around a lot of cars.
I mean, I was brought up in the Middle East. It used to get so hot that all the dashboards used to just crack and sort of fall apart really quickly as well. So all of that work what you're doing is about making things like that not happen anymore, isn't it?
Absolutely. If you think about, I'm a materials scientist, materials engineer, and what we do, everything is made out of materials. And so I use my job and analyse things so small on an atomic level and see what the atoms are doing and how I can make improvements at that level. And when you bring it out into the bulk of a car, you make significant changes.
Wow.
So.
And some of the things you're working on at the moment, are they too secret to tell us or share with us, or is there things that you're doing that you can let us know about?
There's lots of cool stuff going on, as you can imagine, but I think what is no secret is that the automotive industry is changing. We're looking towards electrification, and this is going to happen across transportation, motorsport, everywhere. And a lot of my job is to take lightweighting even further. So if we are going to introduce hybrid systems, battery systems, we're going to have to account for that weight somewhere. And McLarens are famous for being so lightweight. So my job of making a lightweight car even lighter is very difficult. But this is the challenge. And looking at materials and where we can save weight or how we can make things more structurally sound so we can make them smaller, for example, is a lot of what I'm going to do going forward. So I'm really excited for that.
Fantastic. And a lot of people who work in engineering, they have to kind of get involved. So we heard from Sophie earlier, who works in aerospace, but she's learning to fly. Have you driven a fast McLaren?
Oh, wonderful perk of the job, Mark. I don't want to make you too jealous.
Wow.
But yeah, as an engineer, we've got to know what our product's like. We've got to experience it. If we are root cause analysing, we call it, to getting to the heart of a problem, we need to see what that car's doing under that specific condition. And whether it be in a track, whether it be, you know, on the roads, whatever it is, I am fortunate enough that I get to experience this.
Wow. And who are the sort of people who've really inspired you from when you were little to now to really get exciting and enthused about all of this, you know, in the world of engineering? Who's been a kind of really good role model for you?
I believe role models change all the time, and I've had so many different role models depending on where I am currently in my career. But what I love about engineers before me and what inspires me to get into this type of industry are people who you wouldn't necessarily believe are engineers, or who have done something and they're still so true to themselves. And I've mentioned this previously, but one of my inspirations was Alan Turing. And I think his work that he did with computing, the amazing steps he took technology, we wouldn't be where we are today without him. And yet his personal story and his credibility, I'm really inspired by him. So he will always have a special place.
Well, I think it's come now to the time where you've got to inspire all our viewers, which means it's the Paperplane challenge moment. Are you ready for this? I'm certainly ready for this. This is going to be fantastic. Ella, if you make your way over to our experts area, and I will follow Ella over there, and we'll get ready to go. So I think we've got all the bits and pieces over there with a brilliant Lego car, by the way. I've got my whistle, I've got my stopwatch. You've got a piece of A4 paper. We've got our measure. So everybody, we know the rules. I think the rules are up there on the screen at the moment. If you're going to join in at home and send us in your clips, just remember, you've only got 60 seconds. It's a piece of A4 paper. Don't use anything else. We'll see how far you can throw it across your room. The distance flown must be measured in one continuous video. Then you send the video in via Twitter, Facebook, or Instagram. Use the hashtag EOHDPaperplane and include the child's name and age, because there's different categories. Brilliant. So, Ella, have you got a plan? Have you been practicing?
I have got a plan. I've got a few things. I've got some engineering principles in my head.
And aerodynamics are really important in cars, aren't they? And this is quite a lot about aerodynamics and all that kind of thing. So I mean, I'm sure the whole of Mclaren is going to be behind or something.
No pressure.
No pressure at all. Right, let's get 60 seconds on the clock. Are we ready in the studio? Okay, here we go. So count us in from 5 in 5, 4, 3, 2, 1.
Woo!
So here we go. That's a great whistle. Yeah, it worked today. I bet the pin keeps getting stuck.
Right, Mark.
Oh, so you're doing a little.
We're going to go, light weighting.
This
Remember
is looking a little light weighting.
Yeah.
You see, materials engineer here.
Absolutely.
This is what's happening. Yeah.
So that is extra mass that we don't need.
Doesn't want it.
We don't need it.
And you're just doing a fold over the middle there. There's 2 corners going in, so a bit's gone. We'll find out a bit more about why the bit went and the light weighting of this piece of A4 paper. So yeah, that's right. You could start with A4. You could turn it into A5, couldn't you? It doesn't really matter.
Absolutely.
You just have to start with the A4.
Don't be governed
by
by
I better
it.
check my watch. You've got 25 seconds left. This is very technical. There's some very precision engineering going on here. We would expect precision engineering from McLaren, wouldn't we? But you are running out of time, though, which is not like McLaren at all. You've only got 12 seconds left. Here we go. Counting down for 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh my word, that was, wow, that is an unusual looking plane though.
Right,
so it's not got a lot of wingage.
No, it hasn't.
Is wingage a word? Can we even use the? I mean, wingage. You looked at me like what?
Minimal
wingage.
Aesthetics, beauty, and function.
Wow.
There we go.
So, and it actually does look a bit like that kind of McLaren 3-seater shape, doesn't it? Do you know
from the top, the bird's eye view.
I love this. I love it. And is
so
it going to fly?
aesthetics I've done. There we go.
Bring yourself round the front. This is. I mean, if this goes all. So basically, your feet must remain behind the white line as you throw it. If you step over as you throw it, you'll get a DNF. Did not fly.
Okay.
You don't want a DNF on the leaderboard.
DNF.
You've got danger stand 1554. Okay, that was basically nearly the end of the studio.
Yeah.
Mr. World, 6.7. And then Maddie, Greg at the 3 metre-ish. Sophie, 1.4. The ramjet didn't start or something on that one. And Shroot, 0.4 a metre. The electronics failed. Are we ready then? Let's count her in 3, 2, 1, throw! Oh no! Oh no! No! Oh, there'll be some conversations. There'll be some conversations. This is not going to work. Right, well let's measure it. It's ahead of Shroot, just a bit behind Sophie. Right. It's too far for the laser. Hang on. It's coming up there. The end of the studio is 19 metres. I'm afraid to say, Ella, it didn't get that far.
That's a shame.
It's 83 centimetres.
Is it?
83 centimetres. Woo! Well, a big round of applause for Ella there. We'll write that up on the board.
Oh, Mark.
Oh.
Great handling, though. Great handling. Did you see the
I did. It was amazing. It went
Yeah.
around the corners. It did a couple of spirals. It was beautiful. Stuck to the carpet like glue, I think people say there. Yeah. Right. So 83. That's going in there. Gosh, this is complicated stuff. There you go, Ella. 0.83. Fantastic.
Thank you.
Thank you so much for joining us. Big round of applause for Ella. Absolutely brilliant. So, we'll catch you next time. And I think I'm back over here now. Is that right? Yes, it is. See you later, Ella. Thank you so much. Wow. Well, how are your planes doing at home? Are they taking flight or are they crash landing at the 0.83 metre mark? Well, we're going to head over now to Millbrook in Ampthill, Bedfordshire, which is very close to my home, and it's a fantastic place. They test safety, performance, refinement, durability of vehicles, railway, aircraft seats, with full-scale crashes. They've got test tracks and so much more. Let's have a look at Millbrook.
At UTAC, we have many exciting opportunities and routes to join dynamic teams of highly skilled professionals working in a wide range of departments across the business. We provide a great place to work, a huge variety of things to do, and a wide range of vehicles and components to work on in different countries around the world. We believe in developing our future talent by combining education and work experience. Whether you're a school leaver, current student, or recent graduate, we have a career path for you. Our apprenticeship scheme develops with you. The course route that you take after the initial 2 years is flexible to meet your career aspirations and our business needs. An apprenticeship with us is a fantastic way to supplement academic studies with hands-on experience, all whilst earning a salary. Our undergraduate placements are an exciting opportunity to put your academic knowledge into practice on real-life industry projects. Our graduate program is a 2-year rotational scheme, which provides you with the opportunity to work alongside our world-class engineers and technicians in a number of different departments. We create an exciting workplace where people work together to learn and progress. At UTAC, we employ around 1,280 people across our various locations, so there are many exciting opportunities and routes to join. We hope one day to welcome you to UTAC. To find out more, visit www.utac.com.
Wow, that is such an amazing place, and it's literally just up the road from me in Bedfordshire. Amazing. But it doesn't stop there. In our media hub, we have so many events going on right this second. And believe me, there's some great videos and also loads of other stuff in there. So head over to the media hub, obviously after the end of the show today, and see what's happening in the rest of today. And don't worry about that, though. All our events are available, as I said, on demand over the 6-week holiday, so you can catch up with them anytime. But for now, let's check in with you guys at home who are using the hashtag IET Open House on social media. So over to our audience, let's have a quick look. Oh, the BBC is taking part. There we go at the IET Open Engineering House over there. I can't speak today. The Engineering Open House Day, and we hope our contribution will do its bit to attract engineers of the future. I'm sure it will. That'll be brilliant fun. And there we have one from there. This is Jess and Sam, loving having a little look at the open house today. Lots of fab things going on. Thank you for that. That's brilliant. Any more? We got one more here. Have you been watching our IET Open House live show? That's from the IET. Sophie Harker blew us away with her wind tunnel experiment. It was fantastic. That's right. Well, now let's welcome back our IET President, Danielle George. We said earlier, Danielle is a professor of radio frequency engineering and Vice Dean, Faculty of Science at the University of Manchester. And you dreamt of being a scientist from when you were younger, didn't you?
Yes, I did, yeah.
You say your favourite part of being an engineer is that today is different from yesterday and that tomorrow will be different from today.
Yeah.
And that's science in itself, because I really can't work that one out. And we're going to be asking loads of questions from our viewers, hopefully, in a bit. Yeah. Whether we can walk to Mars, or other than a mash mountain, what can we make out of potatoes? And so hopefully you've been sending in all your STEM questions throughout the morning, and I'll tell you what, you're in for a treat. Yeah. You really are, because I hope your engineering brain is switched on. But first, let's have a little look at a video of you telling us all about what you do.
I was at school when my mum took me to a book signing of Heather Cooper's latest book on astronomy. And I remember meeting and chatting to Heather, and all of a sudden science became much more accessible because I'd met and chatted to a real life scientist. But other than Heather Cooper, I didn't really have a lot of famous scientists or engineers that inspired me when I was young. It was all really about the teachers. My maths, my science, my music teacher. I remember one in particular, Dr. Perkins. Not only did he have a PhD, but he'd gone to university to read astrophysics. I remember him showing me his logbooks from university days and looking at these really complex problems he was trying to solve and transforming this murky muddle of madness into something very elegant and precise. That really inspired me. So much so, actually, that I went to university to read astrophysics. So really, when I was young, it was all about my teachers, my family, my mum, my dad, my sisters, who really inspired me, especially my mum. She's just brilliant. I'm also inspired by risk, working on really complex problems that I'm not quite sure if I'm going to be able to solve, trying something new, basically anything that has the potential for failure, but hopefully not total disaster, really gets my creative juices flowing. My boss, when I was a junior engineer here at Jodrell Bank, was Neil Roddis, and he is on my list of difference makers. He always encouraged me to ask, why can't we? What if? And never be satisfied with the that's the way we've always done it mentality.
Wow, so we're really lucky because who have we got in the studio? But Dan, you're back to answer some questions, aren't you?
Thank you.
So are you ready for this?
Oh, yes, I think so.
This is going to be mega. We've got a question from Joseph first. Let's hear Joseph's question.
I am Joseph, and I want to know how a boat floats.
Ooh. How does a boat float, Dan?
Right, okay, great question, Joseph. So boat has two forces acting on it. There's a downward pull to it. Okay, so like gravity, and there's an upward one called buoyancy. So there's the weight of the boat,
yes,
and then the weight of the amount of water that the boat displaces once it goes in the sea. Okay, so you've got two weights and they act against each other. Okay, if your boat weighs less than the amount of water that it displaces, your boat will float. If it doesn't, if your boat's heavier than the amount of water it displaces,
it's not to do with the amount
sinks.
of air in it. It's just the amount it displaces.
It's the amount it displaces. Yeah, yeah. And that's why if you have a rock, and the rock can be this big, but that's quite heavy, and the amount of water it displaces is not very much, so that sinks.
Gotcha.
Good question though, Joseph.
Brilliant question.
Yeah.
Absolutely brilliant. I mean, I've just learned something, so I'm sure loads of our viewers have too. And now we've got a question from Ruby. What's your question, Ruby?
What is gravity?
I am with Ruby on this.
Gravity.
What is gravity?
That is a brilliant. Right, okay, so forces are like a push and a pull.
Yes.
Okay, basically that's what a force is, a push and a pull. And gravity is a force that keeps something like a planet or other objects pulling other objects towards its center. So if you think about if you jumped up and down, you come down again. So if you jumped up, you don't just sort of jump up and then fly in space. And that's because the Earth's gravity is pulling you back down.
But it's not a magnet, it's gravity.
It's gravity.
It's like it's its own force.
It's just invisible force, but it's there. And it's different, on Earth as opposed to the moon. And
so
that's
the moon
why
has
see
a gravitational pull?
Yeah, it's about a third of what the
so
Earth
that's
is.
why they have to have extra weight, don't they, the astronauts?
That moon
but they can
walk
still
sort of thing.
boing you around.
Yeah, because the gravity's less there.
And so every sort of huge mass, like Mars, that has a gravity.
All the planets have gravity. Yeah, they'll be different, but they all have gravity.
Wow.
Yeah.
So there you go.
Good question,
Ruby. Fantastic. I'm telling you, I should just sit here all day. I could go. It's brilliant. So now we got one from Isaac, I believe. Isaac, have you got a question for us?
How do the raspberries go red? How do the raspberries go red? Can you say it?
How do raspberries get red?
Can you say it again?
Why do raspberries get red?
No, we got that. Haven't we? How do raspberries go red?
Wowzers. Okay, this is pushing my limit of what I know about raspberries. But okay, so berries have something in them called anthocyanins. Okay, and
anthocyanins,
they,
right?
nines.
And
Nines.
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 Nines. And that's part of a molecule called flavonoid, okay?
Right.
And the anthocyanin is, it's like a pigment, which...
So like when you go brown in your skin?
Yeah, so it's like a pigment like that. And depending on what the anthocyanin is, it will turn a berry a colour. So for raspberries, it turns the berry
I've got
red.
yellow raspberries in my garden as well.
So that's got anthocyanins that have got
They go
yellow
yellow,
pigments in.
Brilliant.
Yeah.
There you go.
And that's about all I know about raspberries.
Brilliant. Excellent. But I mean, if you ate too many raspberries, would you go red? Because if you eat too many carrots, you go yellow. I mean, people, they have done that, haven't they?
Yeah, well, I mean, it's got pigment, I suppose, so
Yeah.
to change the pigments in
And
skin.
how
I wonder how
raspberries
many,
you'd have to eat to
how
go
many would you
bright
have to
red?
eat?
That'd be funny, wouldn't it? Right, I think we've now got one from Willow, and this is a great question. Now, I don't understand it. I'm with Willow on this, and why is no one else worried about this, okay? Because I'm totally with Willow. She's there in the daytime, and everybody says the moon comes out at night, and you're going along, and there's the moon, and nobody else is bothered. I'm there with Willow. Moon, I'm there.
That's
and
brilliant.
why is
That's
the
brilliant.
moon out in the day?
I mean, we see the moon in the day for the same reason we see the moon at night as well.
But sometimes you don't see the moon in the day.
Well, the moon has, it doesn't have its own light, okay? So stars have their own light, like the sun. So what the moon does is able to reflect the light from the sun, okay? So when you see it, and it does that really well at night because the dark sky, and you see it.
I love the way you're trying to explain this to me, and you know it's not going in. Anyway, so the moon's reflecting the sun.
Yeah.
Right.
So in the daytime, it does the same thing, okay? So it just has to be in the right place in the sky for it to reflect the right amount of light, and as long as that amount of light it's doing is as bright or brighter than the sky around it, you'll see the moon during the day.
And it's around twice in a day, isn't it?
Yeah, so it does circle.
Twice. So you've got the chance of seeing it at night and in the day sometimes.
Sometimes, yeah, depending if
on
it's where it is and if the light
sun's
is
right. And we don't see
reflecting
it a lot in the UK because it's not very sunny because it's cloudy a lot. So we would see that phenomenon less.
Yeah, but we do still see it quite often, as Willow just
I do as well. Yeah, no. I mean,
today.
is it just me and Willow who see it then? Do you know what I mean? It's like totally with brilliant question. That was
it's a great
absolutely
question.
superb. Now we've got a question from Thea. Thea, this is a good question.
How cold is it in space and why is it cold in space?
Ooh,
there you go.
right.
How cold is it and why is it cold in space?
Right, okay. So, how cold is it? So there's a background temperature in space, and that is at 2.7 Kelvin. Okay, so Kelvin 2.7 Kelvin is 2.7 degrees above absolute zero.
Right.
Okay, and absolute zero, if you measured it in degrees Celsius, that we would normally use, would be minus 273 degrees Celsius. Okay, so that's absolute zero.
That's a bit chilly.
So 2.7 above that is minus 270 about degrees Celsius. So that's what it is. And that comes from the sort of afterglow of the Big Bang. So 13.8 billion years ago, we had the Big Bang. There's still this afterglow
There's still
of
the
that.
energy in the air, effectively.
And that's what you're measuring. So that's how cold space is.
So the universe of space is 2.73 Kelvin.
What's called the cosmic microwave background. This afterglow from
cosmic microwave background.
But of course there are still very hot things like the sun. I mean that is very, very hot.
Yes.
You know, tens of millions of degrees in its core and about 5,500 degrees Celsius on its outside, and they radiate as well. So obviously we get the radiation from our sun, and somewhere like Mercury, the planet Mercury is really close to our sun, so that gets quite a lot of radiation, so that gets really hot. We're in just about the right amount of time and space away from it, that we get just the right amount of energy from the sun.
Fantastic. I've got loads of questions I could ask about this, but I think we're having one more here. Yes, we're having a bit of a heat wave in London, so this looks like it's quite a sunny place there. Scarlett, it's over to you.
Dan, I have a question about how when I go on holiday and the plane journey leaves behind a carbon footprint, how do I set that when I get back?
Okay, I got that. So when she goes on holiday, okay, how does she offset her carbon footprint of the holiday when she gets back?
So you can measure or calculate how much of a carbon footprint you've made, depending on where you've gone. What a lot of people do, Scarlett, is plant trees. So lots of people try and plant trees to offset their carbon footprint. And that seems quite a growing trend, which is a really good growing trend.
A growing trend. So that's good. A growing trend. Yeah, a growing trend. Brilliant. Have we got any more on there? I think Joseph has got one for us now. This one is going to blow you away.
Oh, okay, good.
Can we make electricity with cow farts?
Brilliant. Can we make electricity from cow farts?
Bottom burps, I think I was going to call them, but cow, if you want.
Okay, cow trumps. So yes, the answer is yes, you can, Joseph. The reason is it's got methane in it, and that can produce a biogas. So cow trumps and cow poo, that they can both produce electricity. So you'd put like cow poo with some bacteria in a tank. It produces biogas. That biogas can be the fuel to generate electricity. So you have recyclable, renewable electricity from cow bottom burps.
There you go. You heard it here first. And next up, we've got Clara. Clara, come on. What's your question?
Can you engineer an invisibility cloak?
God, that would be brilliant. Can you engineer an invisibility cloak?
Ooh, that's so good. Hopefully I've got a little bit longer to answer this one. That is such a good question. Like a Harry Potter invisibility cloak. So there are engineers who are actually trying to do this now.
Really?
Yeah.
Wow.
They take broadband light and they do something called spectral...
broadband lights? You mean just light?
Yeah, so they're doing something that's called spectral cloaking, okay? So they're taking broadband light, okay? And have you ever done it, maybe when you were at school, you did the experiment where you shine light into a prism and then you get all the colours, because it's not actually white light, it's all different colours at different wavelengths. What happens is, say this car, the reason this car looks green to us is because it is absorbing all of the other colours and giving off the green.
That's
so
bonkers,
it bounces
isn't it?
off.
It's like backwards almost.
Yeah, so it's bouncing off, and that's why it looks green to us. So what engineers are trying to do now is trick it into thinking, right, it's not going to bounce off the green anymore. Okay, so all the light hits, let's say, this car, and then it would change the green wavelength. So it would change it to a different frequency. And because it's green, the wavelength that it's changed to would then just go straight through it. So it would just
The light would go through it?
Yeah. So it would
of course,
just...
if light goes through something, then it would look like what's behind it.
Yeah. So if you had like a bowl of blueberries, you would then change the blue light on your light to make it think it was like green light or something else like that. So now the blueberries aren't going to reflect it. It's not going to bounce off. It's just going to absorb. And so you just go all the way through and you wouldn't see the blueberries. Now, of course, in real life, you don't just have one colour. You know, you'd have lots of different colours. And so the next step of it is can you do that, but with lots of different colours at the same time? If you can engineer an invisibility cloak. So my question is back to you. Can you engineer an invisibility cloak in the future?
Yeah, well, you never know. We might see that happen. And our last question is from Karis.
Can we build a time machine?
Oh, another great question. Can we build a time machine?
Blimey, these are good questions, aren't they?
I know.
I mean, hypothetically, theoretically, it should be possible because we've got Einstein, and Einstein gave us general relativity. So mass objects can distort space and time, okay?
Yeah. Okay.
So Einstein also thought that you could fold space and time. Okay.
Yes.
They fold it together like that. So effectively, think of it sort of as a tunnel that you've folded, but these two ends are in different times and space. But you've managed to fold.
Like a wormhole.
Well, that's what it's called. Exactly. It's a wormhole. Okay. So wormhole. It feels very science fiction, doesn't it?
It does.
But a lot of scientists now think that maybe wormholes do exist naturally in the universe.
Really?
So if they do, and people are using radio telescopes, the type of thing that I work on, to try and look for these wormholes in the universe. If they are there, then there's no reason, technology is getting better and better every day. There's no reason why we can't control space and time in the future. If you can do that, you can build a time machine.
Wow. Well, those were amazing questions.
Great questions.
I mean, they must have tested your knowledge a bit, but it's my brain feels like it's been flooded with knowledge. So that's amazing, isn't it? So thank you, Dan. It's been an absolute pleasure again, and I hope you guys at home enjoyed that. You've certainly put her through her engineering paces, definitely, with those amazing questions.
Yes, we had some great questions there. I hope we've showcased the wonderful opportunities out there that you viewers at home can be part of in the future, and the great things that engineers are doing to improve all of our lives.
So Dan, this is it now. This is the time you've been waiting for. This is the moment of truth. This is when the president of the Institution of Engineering and Technology gets to do the Paperplane Challenge. Are you ready and up for this?
I'm up for it.
Okay, let's make your way over to the...
Right.
Let's hear it for Danielle George. Come on. I'm going to follow you over there and get myself ready. I've got my stopwatch, got my whistle.
I did see something on social media about shrooks, by the way. Someone on social media said, you've been a bit unfair, Mark. You should have measured it from the end of the paper.
I did, but it got kicked, so it's just moves. I can give her a bit more if you want, honestly. We can have a look into that. But honestly...
the end of the paper.
Honestly, we'll have a look, we'll put it there. If I've made that mistake, I can only apologise, Shrik, and we'll sort it out. We'll have a look in the replay. We've got an action replay. I think the Paperplane got kicked. But anyway, are you ready?
Sorry.
Right, you know what you're doing. You have got 60 seconds from when the whistle blows, not before.
Right.
60 seconds from when the whistle blows, and in that 60 seconds you have got to make your paper aeroplane.
Right.
You can't use anything else but a piece of A4. We are going to bring you over here, then you're going to throw it, and we'll go from there. So we're going to count you down from 5, and then you're ready. Have you got any tactics? Have you thought this through? Have you been practicing?
Well, my daughter, my 6-year-old's given me some tips. So
there you go.
Let's
This will go well then.
Let's see.
So here we go. In 5, 4, 3, 2, 1, go!
Right.
And she's off. Here she goes. What sort of plane are you going for there, Dan?
A 6-year-old.
6-year-old plane. So this is. It's actually probably going to be a good. Oh, this is interesting. It's a double fold. Double fold there.
Double fold.
Straight in at the beginning with a double fold. Haven't seen one of those today. And then this is going to be. It's a bit of. Oh, I see. Now this is nice.
How am I doing for time?
Have you actually practiced this, or have you only?
No, I literally haven't practiced. I absolutely promise you I haven't practiced.
Oh, you've got 30 seconds. I mean, there's no pressure at all here, but
okay.
that's the president of the Institution of Engineering.
Yeah, no pressure on that.
No pressure at all. 35 seconds on the clock so far, so she's got 20 seconds.
Were
you hoping to have some time to decorate this one?
I was actually. What am I on?
Oh.
What am I on?
You've got 15 seconds left. 15 seconds. This is an amazing looking aeroplane. I have no idea what this is going to... Oh, hang on. We've got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, you can... What did you... Oh, you got a couple of stickers on there. Look at that.
My daughter said I had to decorate it.
That's a very interesting looking plane. So make your way down to the runway here. And there's not much wingage. There's a little
wingage is a great
front.
word, Mark.
I think wingage is the word of the week. It's my new word.
It's great.
You can put age on the end of anything, can't you? Do you know what I mean? You can have like flowerage and...
Flowerage.
You know, I don't know, watering cannage. So explain the thought process behind your amazing
Well, I've gone for
a
sleek look to it.
But it's got this kind of... I don't know if you can see this. It's got a kind of... sort of wing at the back that's down, and then the wing, and then it's very, very interesting. I hope those butterflies are going to give it extra lift at the front there.
Don't knock it till you try it.
So on our count then, we're going to go for 3, 2, 1, throw. So here we go. This is Danielle George, President of the IET, on 3, 2, 1, throw!
Oh.
Was that what you were expecting?
No.
Let's get the measure out, everybody.
Halfway.
We were hoping somewhere down there.
Yeah.
Oh, it's just disappointment now. I could see it on your face. The disappointment was terrible. So let's get that up here.
When my daughter did it, it went a lot further.
Did it?
Yeah.
That's the trouble. Children are brilliant. 1.623 metres.
Oh, how disappointing.
It's not bad though, to be honest. You're not in last place. So any particular colour for your sticker? Purple, green, yellow, pink? Orange?
I'll go for
green,
purple, please.
Purple? Oh, yeah, purple's quite popular at the moment. 1.623 metres. Right, this is Dan.
Oh,
and I'm going to put IET Prez. Is that all right?
Yeah.
Okay. Can't fit it all on.
I'm not quite sure about Dangerous Dan. Did anyone actually see him do that?
Yeah, we've got it on video. It's absolutely incredible. Yeah, 1.623. We're going to have to squeeze those ones down a bit there. A bit there. Up. And that one up there. God, they really are. They really magnetise on these things. I can't move them. Right, anyway, there we go. That's it. So you're in the middle. That's not bad. Happy with that?
Not bad. Not really that happy with it.
Okay, so to get yourself up here with our engineering experts, some of them anyway, all you need to do is to send in the video of your paper plane making, the distance of how far your plane flew, your name and your age, and put it all on social media with that continuous video using the hashtag EOHD Paperplane, and you could be in with a chance of winning a really cool STEM prize. Terms and conditions apply, so please head over to our website before you join in, have a quick look at that. And we also have the hashtag IET Open House, and if you just want to say hello to our team or get any of your engineering messages or questions out there, just send them in and we'll try and read them and that kind of thing. So as we approach the end of our transport episode, let's take a sneaky peek as what's coming up in the next episode. It's all about energy. Greg and Maddie, what will you be showing us?
Hello, it is so great to have so many of you tuned in to Engineering Open House Day.
Thank you for joining us.
A little bit later on, we're going to be showing you how to harness hydropower, the power of water, to make your own water wheel out of stuff you can find around the house.
But will the water turn the wheel?
Dunno.
Will the wheel lift a weight?
Dunno.
And will we get completely soaked in the process trying to find out?
Yes, that I do know. Yeah.
Back to you in the studio, Mark.
Wow, that looks so cool. And yes, I will make sure I'm standing well out of the splash zone, although with the heat at the moment, I don't know. I don't want to get this T-shirt wet though. I mean, look at it. It's well cool. But now, let's head over to Andrew. But actually, before we do, we must just once again say thank you so much to Danielle George, our president. She's coming here. It's been such a good sport, everybody. Say thank you. Great answers to the questions. Really enjoyed those. So come on, let's head over to Andrew now, who's going to demonstrate how the buoyancy of boats work. How good is that? So he's going to use marshmallow and chocolate. See you soon.
So today I'm going to be looking at mechanical engineering and specifically how can I make a boat totally edible. I'm talking about something that might be able to sail across a lake on your table and deliver some delicious goods, that kind of thing. And I'm going to show you how to make one at home. And as far as I'm concerned, there are 3 things needed to qualify as a boat. It needs to be waterproof, first and foremost. It needs to be buoyant. And it also needs to be stable. So let's look at those in turn. First thing is waterproofness. And when you think of edible things, quite often they tend to absorb water, or what we call hydrophilic. So if you've ever stirred salt into a mug of water or sugar into cream or anything like that, it dissolves really readily. It loves to attract moisture. What we really want is something that's quite high in fat, which is naturally hydrophobic, so it repels water. And actually, chocolate is a really good place to start. So have a look at this. I've just got an ordinary shop-bought bar of chocolate and dip it into the water. The water just runs off. It actually beads and is repelled, and it's because of the really high fat content. The major component in chocolate is cocoa butter, which is hydrophobic. It's a bit like how oil and water don't really like to mix. And you might have seen this if you've been in the park and there's a really waxy leaf that the water runs off, or if you've bought a brand new non-stick pan, the water beads on the surface. So if you have that high contact angle with the water and the surface, generally means it's pretty waterproof. So how does it do as a boat? A little bit disappointing. It's not very buoyant, it's quite dense. And when it comes to buoyancy, density is really important. Chocolate is more dense in its solid bar form than water, so it plunges straight to the bottom. So can we do any better? What can we eat that's less dense than water and is going to be a lovely buoyant boat? Well, you might be one step ahead of me here, but we can use a composite of marshmallows and Rice Krispies, held together by this marshmallow and butter matrix, and then all these air-filled Rice Krispies in lots of little pockets. So let's see how this works on the water. In it goes. Look at that, like a little raft. So it's so light, about half of it is above the waterline. But if you've ever eaten a bowl of Rice Krispies, you'll know that it starts to absorb the liquid. So we'll keep an eye on it, but I anticipate that's going to start looking a little bit sad. So in a way, we want to take the waterproof properties of the chocolate and the buoyancy of the Rice Krispie and combine them together. So how can we do it? Well, I'm going to show you. Let's start with how you make the Rice Krispie composite. You are going to need 100 grams of marshmallows, any colour you like, 25 grams of butter, and 75 grams of Rice Krispies. First thing you're going to want to do is melt together your marshmallows and your butter. So just pop those together and then just pop those in the microwave, just in 20-second blasts until it's totally melted. I'm going to go and do that now. I'll be right back. Cool, so that's totally melted, marshmallows and the butter. So just give that a little mix together until it's uniform. It starts to smell really good at this point. You're going to add your 75 grams of Rice Krispies and then just work those together. So your Rice Krispies are really what keep it buoyant, and your marshmallow is effectively the glue here and is going to help it set into a shape. Now, because I want something a bit boat-like, I'm using a mould. This is just a tureen mould, and I've just put a bit of cling film on the inside. But this is quite nice because it's got a nice round base, a bit like a boat hull. And then I'm going to tip my marshmallow composite quite quickly into my mould before it sets. And then just gently tease it into all the corners of your mould. And this will set up in about 5 minutes, 10 minutes in a cold fridge. And after that, you can just slice it into 3 individual boats in this case. This will make about 3 little mini rafts. And usually I just pull the cling film up over the top just to press it down nice and evenly. And then just pop that in the fridge to set. Okay, so 10 to 15 minutes in the fridge, and this is now solidified. So if you just peel back that top layer of cling film, and then you can just tip it out onto a chopping board. It might still be a little bit sticky, that's fine. Just, out it comes. And then just peel back very gently. And then once it's sliced, it can go back into the fridge for a little bit afterwards. So all I'm going to do is just cut this into 3 little boats, back into the fridge with those, and then all I'm going to do afterwards is melt a bit of chocolate and paint that on top. And like any good Blue Peter presenter, I've got one I made earlier. So I've got a few of these that I made earlier on, and let's just see how this performs over in our tub over here. Now, let's revisit the Marshmallow Crispy on its own. It looked fine earlier, but actually, come and have a look at this. It's got a bit lower in the water. I can see quite a bit of Rice Krispie debris floating around, and actually, when I lift it up, oh gosh, the whole thing is disintegrating and falling apart. It's a pretty sad boat. So we'll leave that there, but its composite counterpart is much better. Here it goes. Look at that. Like a proper little boat. It's waterproof. You can actually see under the waterline that the water is beading. It just runs straight off. Waterproof. Waterproof, buoyant. What's our third thing? Stability. So I actually made a few of these with different shaped hulls. And if you wanted to transport something across the table, you really want to think about the shape of your hull. Because actually, something that's hemispherical isn't the best way to go. And the way to think about this is if you were holding a spatula. So in this case, I'm holding it at the top. The center of gravity acts as a correcting force. So if I was to disturb it, it returns it to its original position. If I was to hold it at the middle, then when a disturbance comes along, we call that neutrally stable rather than stable because it stays in the new position. If I was holding it at the base, then it's unstable because then it's going to fall over. And the same thing happens when it comes to boat hulls. Boats have a center of gravity, which you want to be lower in general for things to be stable, but they also have what we call a center of buoyancy, and that's the equivalent of where I'm holding my spatula, and that's where the buoyancy force of the water acts through. So what you want from a boat hull is when it starts to tilt sideways, more of the hull goes into the water on one side to correct and float it back up, to act as a correcting force. You don't really get that with a hemispherical hull. You get it a lot more with something like a V-shaped hull, or if you want to go for maximum stability, just go for a flat raft. In the real world, you've got to go for a balance of stability and speed, which is why you'll see a lot of boats with something that looks like a V-shaped hull. But they will all very happily bob along in the water. I hope you enjoy creating some edible boats at home too.